So let's try to see if we can refactor a little bit the notebook. I change here the patient for study so it's more clear. And now the idea will try to see if we have even repeated studies so we can actually remove them. We can let's import everything and set up. Studies. It's probably 2. Number we have 102. Our sample rate, approximately as we said the other day, it should be 50. Probably if I can change here, it will be similar, but not close number, around 45. So I choose 44, closer to 44 than 50 actually. Okay, but more or less is what we saw the other day. We can see here, it's going to take a while. We have some clear events. This is not clear at all. God, this is something weird, for example, this study. So maybe it's actually not even useful. Something went wrong with the sensor here. Not with the pH and the other channels. Okay, this is something actually to check. Yeah, we can make a list of things to check. First of all, okay, let's try to see. Let's grab another. At least for the first plots to have something clear. Okay. 5. It's not clear at all. 2. This is a drop, not that clear, but it's a drop. We have here the drop, the drop, the drop, then something here. Okay, just for taking a look. Then we're going to analyze a bit further. What do we have there? Let's copy this. This is our table. This is our. We have number of studies, sample rate. This whole study. Single event, exactly. Then we have the event types. We can put the distribution of event types here. Duration of events. Duration of events. This is a complete set of events. This is marked down. This should be probably one more, and a complete set of events. Impedance and reflux events. Impedance events. Okay, and so we saw at the end of the day it was around 36 seconds. We have then odd events For example, long duration. Then we can analyze them later. We can expand this section a little bit. This wise like this, duration of events, complexity of events. Okay, see if, until odd events, it's okay. So let's see. Maybe we can put it here before the event types. And we have repeated studies or duplicated or something like this. Duplicated studies. Yeah. It is possible that the dataset there are duplicated studies. We the idea is to identify them and keep just only one. Okay. So how can we do this? Maybe can we compare, for example, this pairwise here with the hash in the NumPy array or in the JSON? Can we do something like it's not that big, so maybe we can just do something completely brutal. Study 2, maybe we can use pairwise. This too long probably, no? Oh, maybe we can do just like I'm more worried how long it will take. Maybe we can use just iter tools. Okay, if okay, this is a good thing. If they are different, of course, continue. It will take forever. No, I won't wait that long. Maybe we can just create a hash of the content. Or maybe we can compare the metadata. I can say read. Maybe we can just compare the metadata. And if the metadata are equal, maybe then we can compare it. Okay, maybe this makes more sense. Can you compare pydantic objects like this? I don't think so, huh? Just to see if this works. I don't think it's going to work. Of course not, because they are different objects. So can we compare? Maybe we can dump it in JSON. I can say model dump. Completely sure. This one thing, this is another thing, so they are not equal. They are always serialized in the same way. Probably yes. If I do like this, of course, okay. It is possible that we don't have okay, of course it is possible possible we don't have any duplicated. Maybe we don't have. Okay, let's see. Can I? If I do. Can I add this and try just asking for the shape? Let me copy this. Then we can keep what we need. So I'm thinking just don't read it from disk, but just leave it there and just asking for the shape. Just to see if we can, if we don't have anyone with the same shape. Okay, we can be sure that they are not duplicated. Just to print something, then we can do something later. Okay. There are a few ones. Can we do? Let's enumerate. Can we just, instead of doing this, enter tools, import this combination, these pairwise combinations? No. I want maybe yes, if I do this 1 2 3 2, yes, of course, list. Okay, I think there is a simpler way, like pairwise or something like that. Let's put combinations. I need, okay, combination, the enumerate the study list into, we're going to have Y J study 2. Let's put the list and just hit QDM. At least we're not going to see the final size, but an idea of progress. Okay, and let's see the shapes. Okay, this is completely suspicious. But these are not equal. Well, let's see. Okay, if they are not equal, continue. Metadata 1 dump model JSON. False, 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 false. So they are different. But let's candidates YJ. Maybe we can just remove this thing from here and also this thing, and let's import from tools, import combinations. Let's organize the imports. Let's go back. So let's see, for example, let's pick up the first pair. Study Y is candidate. Okay, let's see like this. Study Y, study J, read the study folder. can we plot both in the same plot, not with this function? Wait, let's don't trust our eyes. Let's one. Let's plot time series y of 0. The series j is the correct way. But they are the same. And what is the difference of the metadata? They are completely the same. Let's compute just to be sure. They are the same. Okay, but not the metadata. No, this sum 0. Okay, they are the same. So maybe we can actually put here this thing. This all integer, so we are talking about 0. Okay, and we have these things 6 and 79, but there are no. Oh, maybe. Oh, I should keep that just an example. Okay, let's do it again. Let's put example of duplicated study. Where are we here? Duplicated plot of a single event. This is okay. Duplicated study should be one less. Even one less. Exactly. And this should be so 4. Let's plot just for completeness. Fixed size, something like this. Maybe it's too big. Time series 1, time series 2. Same things in Spanish. I'm tired. Let's just put something in there. Okay, this is not equal. Okay, now. So we have study is candidate of 0, study j. Okay, thank you. Okay, it's completely big. This should be 5, not 15. No, this should be 5. Okay, something like this, maybe less. Okay, but the metadata is different. So why is that? Metadata 1. So I guess channels, it should be, of course, it's okay. It seems that there are repeated studies but with different metadata. Okay, the channels are the same. If we can just these are the same, but probably not events. They are not the same. So why is that? Let's see. This is a number of events at least similar. No, okay. Which are those numbers? Okay, the second one has much more events. Can we create a function? Study events data frame. Okay, no. Does this work like this? I don't think so, huh? We shouldn't convert it to dictionary. Okay, let's see. Can we lose? Of course not. Data, let's do dump, model dump for M, for E. No, what happened? Format document. Okay. Okay. And then we have this thing, and then we have this thing. They're all pH reflux in the first one, so this is odd. Okay. Can I do on start, end, and type? This is not join, no? This is merge. Okay, it is length. No. So there are no start length type. So we don't have this one, for example. Oh, that's really, really odd. It's in every case the same thing? How can we tell that? Let's take, for example, another candidate. Let's see then how we can improve this. Maybe we can just take the one with the largest number of events. What can we do? Let's see what happened here. Maybe this is events tf. have a few ones, and we have why on earth this is the case. I don't have idea. 58, 44. It's the same data. So I'm thinking maybe some of the events maybe they're the same version 2 times, and the doctor selected a subset in the first one and then completed, and they are saved in 2 different sets of files. We should make a decision here on what to do. Maybe we can merge them, and then we can analyze later if actually makes sense. Okay, these are more or less the same number, but there are no maybe wow, there are a lot of, there's no, how many there are? 4, so it was 8. There are 8 studies. Maybe we can keep them aside. Probably it's for the best, and then we can see later. So maybe we can see later. If we are missing some data, we can just not very keen of removing data actually, but okay, let's point out which are the repeated ones. Which are study list 4. Okay, 4 no. Repeated study Y, repeated study J in candidates. Print exactly, not name, but just this thing. So we have one. Okay, maybe we can just put this one aside for a little bit. Identify repeated studies. Let's identify them at least. Let's do filtered study list. If Y not in, okay, let's create study set. Oh well. No. We started add Y, add J. We can print them. Okay, study list. And what we can do in some other notebook is to see if there is a possibility to merge those set of events, if it makes sense, but okay, for now, filter study list, if not in repeated studies. Let's identify filter before now, a bit less, but the distribution should be more or less the same. We have the same outliers. Okay, more or less we have everything. Even this, how was created this event df? Okay, now we have the function. Maybe we can just, yeah, okay, use that function. Okay, so I would like to strange events. It is always in seconds. How many there are? More than 169. More than 50 we have. These are always in seconds, right? We have events durations. So I'll see around 50 samples, okay, an approximation of seconds. I can live with that. Duration. Can we plot them? Okay, we can plot. Okay, so we also should filter this kind of events. Okay, not bad. So let's suppose that we have a few threshold, which will be okay, filtering these repeated events, and also filtering this really long impedance events, so filtering the repeated studies and filtering the long events. We should be able to create a reasonable data set for this, and maybe we can just inspect. So at the end it will be sampling windows inside this time series. A window of how many points? We should use at least, I would like to have a complete sample, a complete event in the window, or at least the majority of the events in the window. And then we can just create like kind of a sliding window for this thing. So if we have, I don't know, what is this, 50? Maybe we can 50 times 50. It will be a time series of 2,500 samples, which it's actually can be made. So how can we create this data set? So we have, let's see if we can actually in data read study folder, read metadata. We should need, first of all, we should need something like this function. Let's see what we need. We should have a list of paths, and we should receive the dataset path here. Okay, so we have this thing, then we can filter out those repeated. Maybe we can just create a function for now and then see. Let's see later. For now, let's create a function for this. Detect repeated studies. We should take our combination here, put it right here. Let's import the QDM also. We have, okay, a study list, okay, exactly. And we return the set of candidates. Here we can just call from data detect repeated studies. Wait, okay. And then we can just detect and repeat the studies. For filtering out, okay, this is, we should need to create this thing. So what should we do? So maybe it's just, we have the time series, we can create windows. Maybe what we can create is just an additional column with ones when the event is present, with 0 when the event is not present, and then using like the Keras utilities for time series and just creating the time series in Windows. Maybe we can do something like this. It should be doable. Let's try to create. We can then we can go on with the era in the next iteration. But for now, okay. Yes. Let's put again introduction. Setting things up. Then this is just a way to create a little bit structured, and we can create just proper proper entry points for training the model and not just in the notebook. This is just for quickly prototyping. Okay. So first thing first. So this should be like this. Okay. Don't complain anymore about this, please. Okay. List studies. Also, let's use this in the EDA. Since we already did the function, why don't use it? That's right. Okay. Let's copy this, then we can remove what we're not going to use. Let's copy this. Come on. Then we can call directly to detect blah blah blah, detect repeated, which would be like this. Let's call it repeated studies, and then we can just filter them out. Maybe we can just, no, I would like to know the tuples for this. Okay. So maybe you can just create a function. We have the load function, which is read the study folder. We can just grab one. Maybe we can, I'm going to create it like this, but then we are going to use a proper function for event, metadata, events. Let's create first of all, target will be, let's make it explicit. Okay. Event start is event at the start, event end is event start, event length. Maybe we can do something like this, really fast and really cheap, and then we just can like this. We should always, okay, perfect. So if we plot this, let's create a function out of this. Let's add target column, time series, and the array. And then we can just, it's going to make a copy, but okay, we are not dealing with big data, so then we can document a little bit all of this. I'm going to do it later. Add target column, so maybe we can do just like this. Import name error. Okay, not that bad. Add target column. Maybe I didn't make the reload, right? Reload, go, config, filter everything out. Add target column. Can we plot this? Just two channels. One a few things that we should do. Time series 1. No. That's right. I don't think so. I misput the shape, right? Shape. No, shape the 0 is right. No. Okay, I'm a complete idiot. Okay. Okay, so we have this. I'm thinking, so probably it's not going to work just a naive approach like this. Maybe we should undersample at some point the complete empty portions, but we will see. And then we should scale everything. So I guess in this case we can just scale everything to -1 and 1. There is this 4,000 things. Push everything to the top, which I really don't like. For example, this studies. So one thing, okay, maybe we can create a to-do list for the check studies with large portion of constant values to see if we need to drop them. Okay. One thing that maybe I can recover. Okay, for example, in this case, this is not going to be used, just scale it by 4,000 and not for that much, and then clipping everything. Okay. Which were this value scale of this thing? 4,000, 4,000. Let's can see. Okay, this is 4,000 for this one, and 3,000 for the DPA. So maybe we can. Okay. First of this, we can create something like this, or just. Maybe we can compute the maximum and the minimum. God, I'm afraid. Okay, let's put some values, and then we can compute them quantile for maximum or minimum of the whole data set. So we should do something like minus max value, min value. So we should do something like this. Now, no. This is why I don't see any difference. So minus min is like pointless. This 4,000. So let me put here max. I should divide everything by 4,000 basically. Why I don't see that? Ah, beautiful. Assignment destination is read only. Ah, because yes, what we do before. Let's put everything that is supposed to be. Okay, and then we have why do we have this? 4,000. Come on. Okay. Oh, okay. Okay, this is okay. Time series as type float. Let's divide it. Okay, we see something with some sense finally. Let's open. Okay, so one of the things that we were trying to do is to obtain for each of the channels which are the maximum and minimum values, so maybe we can do that. So now we're trying to get the minimum and the maximum value for each of the channels, so we can then scale them in 0 and 1. So maybe we can do something like maybe the minimum of the minimums and the maximum of the 99 quantile, so we can just remove everything. So that not remove everything, but we can have something simple for working on. Then we can see how we can create a class out of this, like a scikit-learn transformer. Okay, let's see. Let's if okay, enumerate this is no, it's not enumerate. This is just like this. If channel not in out. Let's write something like this. Else. Okay, this is awful. But okay. So again we'll have something. Okay, I should import everything. And then maybe we can create a scikit-learn transformer. And oh, the dataset is not mounted probably. Let's see. Okay. Why is it taking so long? So my disk is probably my disk where I store everything is a bit old and it's dying slowly, so maybe that's why it's so slow today. Okay, but I will use it until it's death. Oh. Is that okay? Okay, let's see how long. Okay. This is the combination, right? Maybe we can just go like this, so we can have a clear estimation. Oh, my anxiety kills me. Okay, 2 minutes. It's too long. Because it's comparing everything against everything. Maybe you can just save this somewhere. Maybe we can create this what this is misspelled, repeated, write like this in English, repeated, repeat, oh my god, repeated studies. Okay. Maybe we can just with open, maybe we can create a data path. No, oh my god, what happened? This is not the keyword I use in my daily job, so I miswrite a lot of times. Maybe we can just repeat study is a list of tuples. I can say JSON dump repeat studies, and maybe I can do something like repeated studies JSON. Let's create init. Okay, from pathly import path, let's create package path. It will be basically this data path. We can, let's make it relative to this thing. I'm thinking if we should create a data path in home, maybe where the config thing is. Yes, maybe we can just make the data path the how you can, okay, let's call it, no, not data, like private configuration, home. Okay, let's call it package data path. It will be like this. Config path will be like this. We are going to put it right here. We can import this. And we can also actually, okay, let's put it here, and then if we can change it by an environment variable, we can do that. This will be like this. We can data path encadir parent exists, okay, something like this. And in here, data path, let's try to import it. I don't know if we should create a folder like that in the init. Probably not. Okay. And then let's import JSON. Let's organize the imports here a little bit. Let's try to do this. JSON dump. First of all, this thing work. JSON is not dumps. Object of type set is not JSON's really. Okay. Oh, I have the because already it's a set. Okay. Let's try to do this one more time, last time. And then we can just do, if everything works good, read, and we can say repeated studies indices is JSON. is received. Okay. And then we can do with the studies. This is something. This is wrong here. Okay. It's taking really long. The data path is in home, so maybe we can. Okay, this is empty, which is reasonable. This is the same thing. So let's try to, while this is working, let's try to go in here. We have the study list. We are going to, for each of the channels, taking the minimum, then taking the 99 percentile of the data, because I saw there are a few anomalous values there, which is okay. And then we can take the, for each channel, the minimum of the minimum and the maximum of the maximum, at least to have a reasonable number to scale everything. What we can do in the meantime, probably, can we just create transformer mixin for cycle, just to have it like a, we are not using that much scikit-learn, but let's for having this it's like a min-max scalar, but for each time series. So per time series min-max scalar. Let's transformer mixin. Oh my god. Then maybe we can just code it not here, but just directly in model.py. Let's see if then we can create some other module from this base estimator transformer mixin. Okay, I don't know what it did, but it's not what I want. So let's put fit. I will receive. Okay, for fitting I will receive a list of studies. Then we can just do this. Self dot value extremes are going to be dictionary. This is our study list. From typing, import the list. From paddle leave, let's import. Okay, let's import this thing. Let's put something like this. Let's show progress. If self, oh my god, if self. Let's do something like this. Let's do this. So we are, oh, something missing here. If so, okay, if we want to show the progress, we just wrap it inside GQDM, and then we iterate over the time series. Let's use this self self, and we return something of this type. And then we transform just one, I guess. Or maybe we can do something like this: union np ng array, and we of course return the same. We should have the inverse transform probably, but not for now. Okay. If it makes sense. Okay. np ng array, and we have for each channel the subtract the minimum and make the max. Okay, I think it's right. Thank you, Copilot. This will be in place. I would like this to be in place. Let's create a copy. There's a way not to create a copy like this. This is a method for, okay. 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 Let's organize import. So we have this thing, which I have the get. No, I don't have any get params, but yes, for saving, right? If I want get params, I think here I should put everything. I need to serialize the thing. Okay, params. No, this is for base estimator. No, but it's just the constructor, not. Okay, this is private. Get params. Get the params estimations. Okay, but these are params, so maybe we can then pickle them. Okay. Pair time series min max scalar. Okay, so I guess this JSON dumps here. What do we have here? Okay, and then we have JSON.loads. Okay, I don't want any errors. Let's do it again. Maybe we can do. Okay, let's create this. Okay, now chill. Repeated indices file. If not, let's do this. Then this. So if the file does not exist, we calculate everything. The study list is always red, so maybe we can do it just like here. If this does not exist, then we can see later if we want to keep them or not, but just we try to keep going forward until a bigger wall. Okay. If we find the file, if we don't find the file, we compute everything. If we find the file, we just load it and filter. In the meanwhile, let's try to instantiate this class scalar, show progress through, and let's scalar fit our study list. Let's wait for this to end. Oh, please, come on. Okay. Okay. We can do something like this. And we can do something like this and be happy. So okay, we have this static filter without waiting for the thing to finish. Then we have this model not find. Okay. Why? Is model.py. Let's try again. What is the import? Let's put it a bit before at the beginning. Okay, that is reasonable. Scikit-learn. Okay. This thing good. Let's try this. Okay. We are fitting, and then let's see, just to try if this is working. How do I? Oh, maybe I can. No. I prefer to have the matrix instead of the file. I was thinking maybe with the transform can receive the file, but I don't like that idea. I prefer to receive the NumPy array. We can just load it beforehand. Oh, it's yellow. Before it was blue, right? The scikit-learn plot. Not fitted. What should I do to make it fitted? I just have to make this fitted in true. Fitted. Check is fitted. It's fitted. Okay. With a trailing underscore. Model. Of course, this will be false, and at the end, this will be true. And then we can make a static list at 0 and make a scalar transform times 1. Okay, it's blue because it's fitted. Okay, this is nice. And let's see, we can remove this. Maybe we can just also clipping. Okay, let's see, let's just plot it here, the transformation. We should, as we saw the other day, casting everything to float. So maybe, okay, cast to float, maybe this is too much, but it's fitted. Okay, I think it's, I mean, there is not a cast thing in scikit-learn, just not clustering. Cast, no, probably no. Okay, just make it. Okay, we have the cast to float. Let's import it. Let's make pipeline. Let's cast to float. Then this thing, can import this from scikit-learn? Yes, from scikit-learn, make pipeline. Let's organize imports. We have our pipe. we fit our pipe with the study list. The problem is that this will return. I don't want to have everything in memory. No. Okay, maybe I can cast it here in the scalar. Yeah, instead of creating a new class, because otherwise I will have this receive this should receive everything, but it will receive a list of paths. But then when this will call fit, then we can transform with a list of path. Maybe I'm thinking about using polars right now, but no. Just don't make it complicated. As type, yes, don't. Let's don't create everything complicated. Let's go like this. Okay, let's remove this then. Scalar. The problem with this approach is we can have, so maybe I should remove the scikit-learn dependency. Okay, this is working. Because in this case I need, for fitting, I need something different for fitting this. So probably I will take this. I will keep the same interface, but I will remove it just for now. Let's see later. But okay, the transform is working. So we have, let's put 7 and let's do 4 plot time series. If I do like this, no, of course it doesn't work. Let's, and it's 0, 1, 0, 1, 0, 1. This is 0.5, but okay. Respect to the maximum value, it can be 0.5 will mean like a pH value 5 if we think of a maximum of 10. So okay, maybe this is not unreasonable. And then we have the other ones, 0, 1 without anything strange. Maybe we can open a new one. Okay. Other thing to do, so maybe we can do something like then. Okay, then we have the clipping thing, so we can just clip. Then we can, okay, let's make exactly this sequence of steps. Then we can do the first 7. So we were going to discard the last pH channel here, and then we have the function, I think, for adding the target column. We did it the other day. A target column, exactly. We need data. So what I need, let's put everything like this. Metadata is, and we have right now okay, and then we just need to split it. Okay, let's first of all let's create this can be a function, be def transform study prepare study. This will receive a study as a path. Study path will be a path. This will be this. Okay, let's return numpy array for now. So basically we are, let's remove. I need the scalar fitted. Okay, let's go here. And we can import this. Maybe we can move this to model. Let's import this. Oh, and I need the scalar. The scalar should be fitted beforehand. So maybe we can create a class study preprocessor. We can not this. Maybe we can just create self-scalar, something like this. We're going to call fit in the list of studies, exactly. Then we can call transform and perform the complete set of steps that we want. Okay. And then we have the study preprocessor, which is pretty reasonable. We have this preprocess. Let's remove all of the others imports organize. Okay, let's take this. No, matplotlib for now is going to leave it because it's going to be useful. NumPy probably also, but okay. Let's remove this. Remove this, it doesn't exist anymore. So okay. So we have this. We can fit, and then okay, let's see if this works. Okay, and then we can preprocess transform, something like this. Let's see. Okay, not bad. And now I would like to use the time series. What is the function? Time series data loading. Exactly. I want this without the target. I can split the target later. Okay, let's probably I should install Keras, UV add Keras, Tensorflow, CUDA. It will take forever. Okay, what happened? Ooh. Cannot be used because Tensorflow depends on NumPy. Oh my god. No, but I'm using, which Python am I using? UV Python pin. Python, maybe it's in the PyProject. Let's see. 3.11. What is taking the 3? Maybe for some requirements on NumPy. 222. Can we make it a bit more? Oh God. Let's see if we can, if we remove this and do this. Okay. Okay. I put a lower version of NumPy apparently. Okay, not bad. So, going back here. Okay, let's try just to one of the. Let's import for now here, then we can remove it and put it in the code from Keras time series dataset from array. Let's time series sequence length. How do I know what? How do this know? This, okay, exactly. I should put in targets, pass none if you want, exactly. So I don't want the target because otherwise it will take me, it will put me like the horizon or just one sample for predicting, and we want the complete time series, split it, and then I'm going to do something like exactly this. Required position. Why is not defined? Because no, not exactly. I said exactly this, but it wasn't exactly this. It was completely different. So we have like everything here and 0 until 8, 0 until 7, and exactly. Let's see. I say exactly, but let's try as NumPy iterator next. Python object must be callable or have a callable write method. In which part? Okay, list. Method. Can we do this? It will work. Oh my god. No, but I will kill my computer now. Let's do. Why it doesn't like the next? Because maybe because it doesn't. Okay, let's data. Okay, see, probably was the printing thing. Shape. It's a tuple. Okay, not bad. Oh, it is okay. Let's budget ourselves. Okay, we have 107. It's our first window. We can try to plot it. My God, we should see. One, two, three, four, five. X plot. Complaining about something, but I don't know what exactly is complaining. This is NumPy array. No, maybe it's a data type. This is a Tensorflow thing. No. Oh, maybe because I changed the NumPy version during the. Okay, let's. Yes, probably. I kill everything with that. I changed the NumPy version while running everything. It's not a good idea. Okay. Because if we have this, we're almost done with everything that we need, at least in the bigger parts. Then of course we have to refine everything, but okay, let's see. We should see, oh my god, data, and then a line, exactly. At some point we should see some ones in here. One thing that we can do is in a study list, maybe we can, because otherwise I don't want to have everything in memory, or maybe we can tf dataset, tf dataset. We how can I combine the data sets? Okay, well, then we should split these in train and test and everything. This is just, I will want to receive a list of studies and return Tensorflow dataset just ready for being fitted in the model. Then we can split it and call this function. I would like to create tf.data.dataset. I can say something like this. It's not like this. I don't want to. I want to concatenate them. No, not layers. Data. Datasets. From generator. There is a concatenate. Ah, but this is a concatenate B. Okay, maybe we can do something like that. Dataset ETF datasets of 0, 4, something like this. This works. I'm a bit worried about the memory. Okay, I think. Oh, it's not responsive. No, yes, it is responsive. Okay, it's going to explode. So what we can do is the following. Here we can just save the dataset. The save is saved in which format? Dataset.save, and then I can load it with this will load path. Is there a way? Okay, let's try to do this. Let's create data path tf datasets. Okay, tf dataset dot save. Let's try it like this. From ph set import data path. Oh, because I kill everything. Let's start from the beginning. There are a few things not installed. Okay. CUDA warnings. So let's see if we can save and then load them without. Let's see what ChatGPT thinks about. I have data sets. I would like to save them to disk and then load them and create a big Tensorflow dataset out of them. Is that possible? Oh, I'm really prompt engineer myself, huh? Let's see, we have save, load, and then I was thinking in sample from dataset for if we want to shuffle them, so at least we have some kind of shuffle kind of free. Okay, let's see this. It's doing something. Okay, so everything crashed, but I'm back. So a few things. We have our transformation, our data set. I put it what we saw the other day, around 50 seconds times 50 samples per second. So I put this number at least for testing, casting everything to float 16, since we don't need that much resolution on the floating and we can spare some bytes, and then the splitting. But the save is still killing me. So probably we should, I was asking ChatGPT, let's try with the record writer. Maybe we can let's save tf dataset, because the while I was using save, I was running out of memory. So okay, we can just do like this, and we have float list, but also I should need here somehow the dimensions. Yes, because this is the dimension here is missing. This should be okay. Shape. Okay, no shape X. So with shape X, I can deduce the shape Y because it's going to be just one, and it will be okay. So let's see. So we have, okay, let's see if we can run everything. This should be, let's call, then we can put the proper function for this. File name, I would like to call it study, this will be study path, and then we can put study path name, and we can put a study here, and the file name will be like this, tf record. And let's try to run everything, and let's check for each top to see if we die or not. I don't know how long it will take this, but okay, let's see. So one thing at a time. If we can build this, then we'll try to load it, and if we load it, we are ready at least just to call the first fit to see what happened. Where are we? Okay, we're about to start. Let's hope for the RAM at this point. Okay. Oh, this is perfectly fine. Let's pray for the RAM memory. Another error. Is a directory. Let's erase everything that is okay. And let's do play. This is slow as hell. Going to take 10 minutes. Out of range, end of sequence. Local random. Okay, this is okay. I saw that error before. Okay, it's not eating my memory, but it's really slow, huh? They know if this TF, probably the iteration is slow. TF record, writer slow, is so slow. No, but maybe we can just avoid this and just. It's taking too long, 10 minutes for it's not that big, this data set for 10 minutes, or maybe I'm too anxious. It seems too slow. Is iteration that this is slow? I'm not the first one with this problem. Workarounds to multi-processing, yes, of course, but when no, yes, but should do this. But I don't know if I want to do this. So this is iterating, this is calling serialize example. Remember, it's not that big. So I don't know exactly how much my disk is, but I'm responsible of this with respect to the slowliness of the iteration, but I'm calling right for every single example, and I think it's too much. Oh, I don't like this. Tensorflow, save dataset memory. Use Tensorflow. This is January 2023. But why is using the whole memory? It doesn't make any sense. Maybe there's like this thing of growing. There is a way to avoid using the whole RAM. Two TensorFlow data set, but it's probably not the thing. It's today to tf.data. So what is 2tf? This is Hugging Faces. So this is going to be a way, at least slow. Can we do it better than this? TF record writer. A class to write records. Okay. Write. It's just a single record. And if one uses this, for example, save compression shard function, to enable checkpointing. Backwards compatible. But then there is something there with the memory usage. Why is keep rising the memory usage after this? So what happens if we do like this and create tf data set from study? Let's put this. Let's send the preprocessor, the study path and the out path. Just look like this. It's a matter of being everything in top level. Maybe we can actually take it out from here. Let's put this like this. Study path. So let's comment this out. Dot save. This okay. Run all. So I have done this at work, but I don't remember exactly how. So maybe I can take a look in my code. I did actually something really similar to this with a way bigger data set, and it wasn't that slow. But maybe because the computer I'm using at work is way faster, so who knows? This is okay, and the memory usage 16, but not that big. 17. Why? So I guess these slowdowns are my disk. This is okay, but why on earth is using that much RAM? And wait, it is okay. It's really small, the dataset. I try collecting. No. This doesn't make any sense. No. Why? Why is increasing? No. It's like it's still in memory. Can I? No, I don't like this. How do you do this in TensorFlow? Memory instead of GPU. I know that I'm using the CPU, but there is a way. No. Did I say TensorFlow? No. Maybe there is not this. How do you call it? A structure with width, something like this. What happens if I do this? I just probably it won't change anything at all. Just hoping that inside the width structure, which I don't remember the name, it will release the memory after exiting. I don't know. A context manager, exactly. Because this is loading everything in memory. It's not that big, saving it, and then why it's still in memory. I don't understand that. Release memory, TensorFlow dataset. Massive memory. Okay. No, I don't know. I'm not interested in that. Not this one. Okay. No, it's just the same thing. Why on earth? Let's stop it. I'm not actually, I'm just saving it to disk. No, not even training, not even doing anything. Okay, we can just iterate it and stored with tf records. What is this? Random pages. That's datasets. Not release memory. Is that a way of releasing tf data memory? Hey, I did this, but okay, let's try with the, but I tried already. Okay. It's not going to do anything at all. Gel. Still. Okay, no. Okay. If not, I can just write it like this and wait a little longer. What can I do? No, look how it grows. Lovely. No, I don't like it. You shouldn't be growing. Why? Okay, let's select this and be happy with what we have. You're going to X, to Y, the shape X, the serialization. Let's remove this, then we can just create a nice function for this. And let's remove what we have here. This is my disk. Trying not to die. I kill this. Okay. If this works, we can just create a function out of this, and then we can receive just directly the subset of a study we want to create, and then we can do the split validation test, the train validation test splitting, and then calling this function for creating the data set in disk. Okay, this is actually a NumPy iterator. This is ending at some point because of this. Okay, I will wait. What do we have here? Okay, files. Okay, I will wait and then I will resume trying to load this being shuffled or not shuffled to see if we can actually start the training, see what happened, and then restarting from scratch when the predictions are not that good. So okay, let's see later what happened. I'm still not very happy on how this thing is in terms of performance. It is too slow for my anxiety. So let's try just try to launch it in parallel. Okay, something like this exactly. We can just, does this work in a Jupyter notebook? I don't know, but maybe we can just, it's time I think to take it out from here. Let's put for now here. Let's def create Tensorflow dataset. We have our study list. Okay, let's receive our preprocessor, which it will be. Okay, import Tensorflow as tf. Our preprocessor will be the study preprocessor. Okay, not here, but here. We can just import it. We can put like this. We can import this. We can remove it from here. Everything from here. Let's organize imports. Okay, there are a few things here. Organize imports. Let's max workers. Maybe I can do map. This is a function. I should copy if I had map iterables. I should do iterables is a if each iterables argument are passed, function must take that many arguments and is applied to the items. So I can do like my first iterable should, maybe I can do something like this, lambda, or maybe I can define here create TensorFlow dataset from a study, my inner function, can I do something like lambda, I should put the TQDM here probably. Format the one. What happens if I do this? went crazy. Study list, preprocessor, out path, max workers 5. Circular import, okay. This, where do I put it? Oh no, this should be in model or dataset or something like that. No, let's go from here. Data. Okay, not here. Time series, Tensorflow, triple executor. Let's move it to here. Let's organize the imports. Let's import this again, just from another side. Data path is not defined. Come on. I didn't remove anything. It's doing actually anything. Oh, path. So I had to use processes list. Oh, inside here. Oh, I really don't want to. I can just pickle the preprocessor. See, it's calling 5. Forgot to remove this because maybe now the bottleneck is the writing. But this is not updating, so maybe it's okay. I should put like this tqdm list. Let's remove this like this, so because this is going forward. Oh my god. And let's remove the print. So this is entering here. So we are collecting in the list now, but then I will have to wait for everyone to end, and then the QDM will be updated, no? No, of course, yes, no, I'm not going to see the QDM working. No, that for sure should be like this. I cannot see the progress in here. The progress with the QDM in here. It's lazy. Okay, okay. But what is going on here? Executor submit. Okay, maybe so. The map it will. No, okay. This is going to return when using the return iterator. Is it okay? Maybe okay. This the submitted tasks. This should start automatically, and then for probably not like this, but the as completed. As completed. Why did it create a set for URL for? Okay, but okay, I don't need a result, so for me it's absolutely okay just doing like this. It is concurrent futures, right? I can do something like this and wait for the completion, basically. So interrupt. Okay, restart. Come on. Now it's going to work, probably. What did ChatGPT say? Okay, see. Yes, it's similar. Yes, I did this. This is exactly what I showed you this, but what can I do? No, still not showing the results. Because I use map. Oh my god. This is submit. The submit, it will return a future. Then I can do just like this. S for study list. And for submit, I can submit it like this. God, this is submit no map. Yes. Okay. Oh, I was really willing for wasting time, huh? See, I tried this, but okay. Okay, this return an iterator, and then I should iterate for this, asking for the future, okay? Or maybe don't, maybe not there. Not at all. Oh yes, finally. Okay. We didn't gain any improvement in speed. Okay, now we are bounded by my dying disk. Okay, doesn't matter. At least we have the function for creating the dataset. Okay, for me it's good. I'm going to restart everything and remove everything that is here. And close this, put run all, and then in the next time we are going to load, hopefully, this dataset and start fitting our model.